Hello everybody, got another project I'm going to do today. I've got a 60 amp power supply, analog, got a 100 amp switcher, 100 amps continuous, right there. And we got an 18 farad cap for smoothing out transits. So, I do not trust analog power supplies on, high dollar equipment. Regulators short, they pass 25 to 30 volts to your equipment and fry it. So, homie, don't play that crap. These, when they short or blow up, they just shut off. So, we are going to proceed to gut this 60 ampere, clean it all up, take some measurements, put some, AC, DC meters on it. We're going to gut this. We're going to take this bad boy's guts, put in here, and then we're going to take our 18 farad of caps. Obviously they won't fit in there because they stick too far to fit in. So I'm going to take this apart, take the caps out of it. They're going to go into it. And it's, well, from the outside you'll be none the wiser. And it won't weigh 70 to 80 pounds that this thing weighs right now. This thing weighs a ton. These don't weigh nothing. So, I guess I'm going to reposition here and set the camera on the tripod, and we'll start taking some of this stuff apart. See ya in a few minutes. Alrighty everybody, here we are. And yes, for all the haters out there, yes, I'm doing this on the floor. This thing weighs a lot. You don't need to be digging up no benches. You're dragging and shoving it around. Right here on the floor would be great. So, like I said in the intro video, we're going to take the 60 amp Astron, that 60 amp surge. So it's probably around 50-55 amps. Well, that's kind of useless to me anyways. I draw a lot more juice than that thing can supply. So we'll take this 100 amp over here. We'll do some surgical implantation. Now, I did this on an amplifier. Turned a linear amplifier, for those that do not know. Turned a tube type 600 watt 3 tube 811 A amplifier into a solid state, and boy did I get razzing on that. Oh, he destroyed a tube amp and he put a solid state amp in it, and well, that's kind of weird. It made logical sense to me. 600 watt tube amp or 1000 watt solid state. You tell me. I think it made more logical sense to go 1000 watt solid state. Plus, the 811, hence its name, used 811A tubes. And 811s used to be good tubes, but since there's nothing but a China manufacturer, 811s go grid collapse very often. Well, here we go. This is what we need to gut. Take out this wimpy transformer, all this other crap, and start getting some work done. I'm going to save as much of the wiring as I can for interconnects inside the new amplifier. I have more behind me. anymore. You know, different colors, styles, stuff like that. Just gotta tin them and put ends on them. But that's irrelevant. Main thing is breaking this sucker down. I'll pop this off. And we're gonna snip this free. Oh, and by the way, back to the 811A amplifier. It was not the transformer that went bad. It was the multipliers. You know, the rectifier, the diode multiplier. A tripler, to properly put it. Well, that's what went bad. It just wasn't worth repairing. Not since the original owner screwed it up, sold it to somebody. I got it from them. You know, so I had to repair it. And it blew up. And then, you know, after that, you know, I repaired it. Used it for a while, did alright. And then the voltage tripler diodes went to hell, so I said, screw it, done with it. That's enough of that. So I guess pretty much all we got to do is start breaking screws down here and start getting some of this archaic analog crap out of here. Power supplies I use are pretty quiet. They do not cause RF noise in equipment or nothing. Plus, like always on rebuilds and upgrades, I'm going to end up with a lot of excess, spare, pretty useful parts. Nice filter caps, really nice heat sinks. Transformer, I'll give that to Mark. And of course, the case. Alright, I'm going to get up, pause the camera. I don't think you want to see me undoing each and every little item in here. It'd be a forever video. I'll just start doing videos at different stages. And that'll be good enough. Because this is going to take probably, well, I like to do things right. Just when I built old Sammy's power supply, you know, I sat up all night to do his power supply. I got no gratification, you know, gratitude for it. But, you know, that sucker took me all night to do because I wanted to do it right. The only problem with that power supply it was an old power supply, a 2-cord power supply, 2-wire power supply on the power cord, and it needed a third, you know, earth ground. So he ended up with getting a little bit of RF noise out of the power supply because it's only got a 2-wire power cord on it. Other than that, see, him and I don't talk no more. But other than that, that amplifier that he's got from me, the power supply, all that stuff's working great. I'm sure he would have everybody believe that it's not working. But if it was not working, oh sweet, that's a nice chunk. I'm sure, you know, trust me, if it was not working, you would not hear him. Because without it, he is only like S2, 2.5 here at the house. And with it, he's just about S7. So, yeah, it's working for him. So, alright, we're going to get back to business here. I'm going to strip all this out, clean it all up, and keep a nice game plan on how I want to lay this all out. Like I said, there's not enough room here for that cap in its entirety, as you can tell. So there'll be enough room in there for the raw caps themselves once I disassemble this to implant them once everything's in there. And that is not to take the place like a capacitor in a car stereo. What this does on a switching power supply or any high capacity capacitor is it smooths out what they call the transits. It's switching power supplies are meant to have a continuous load on them. They're not meant for like sideband where the load's like bam, 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 bam as you speak. So it's really hard on the switching circuits in the switching power supply. And they'll work, but you'll watch the voltage really fluctuate because they're not meant to switch up and down that quick. So you add a cap like this, it smooths those transits out. Once you've used the surge of the cap, it spread the timing out. If you were to look at it on a scope, the waveform, it would spread the waveform out enough to where the solid state switching of the power supply is a lot more efficient and a lot less, switching time to it, because this takes up where a lot of switching is not needed. So these work really good. You don't need this kind. A 2 farad cap, even a 1.5 or a half farad would work. Much less than that, like using stuff like these would not do jack crap. But like a half farad cap at minimum, you'd start to notice an improvement in transits. So, all right, I'm going to get off my lazy ass here, pause this camera, start pulling everything out of here, and save as much of this wire for interconnects as I can. It should be golden. I might actually be able to get this testable today. I don't know if everything will be mounted permanent. We'll see. It's 12:34. So just a little past noon. We might be able to do this. Depends on how elaborate I want to get with the wiring inside. So I'm going to throw these 2 videos up on the YouTube or on the Facebook, and stay tuned for the next little video segments that I do on this changeover from dinosaur analog to updated 100 amps continuous digital switching supply. Get y'all in the Facebook. Alrighty, folks. We got most of it done. Well, not done, but gutted out. We ended up with some spare garb. A couple of cool things that are actually useful. Like we got a couple of ample-sized heat sinks. I don't know about linear heat sinks, but keeping regulators cool, that should be sufficient. Got 2 of those match. 2 pretty good sized filter caps. AC induction fan. I took it out because I'm going to run a DC one. So I'll still utilize the grate that goes on here. We got our massive transformer that came out of it. As you can see, we got to clean it. Pretty filthy inside there. But main thing is getting this heatsink compound all out of here, because you touch the shit, and everything you touch after that is heatsink compound on it. So, get rid of the heatsink compound. Some back here on a regulator I took out. That in the garbage. And get the brushes in there, start dusting it all out. Looks a lot better. Ample room to build in. I didn't take this heatsink off because it's riveted on. I could drill the rivets out, but it ain't causing no problem. Excuse me, pardon the coughing. As you can see over here, we got miscellaneous interconnect wires we can utilize. Plenty of hardware. So that makes things easy. I got a pile of hardware over there. And then I got utility drawers full of sorted hardware. Power transformer was a little bit of a bitch to get out. They had Loctite on it, but they also had the threads mashed. So, yeah, that was a little challenge to get out of there. I don't think they ever expected that to come out. That thing is heavy. But from what I'm suspecting, well, of course, these are the ACNs, which it takes a lot of juice. The freaking primary windings on this thing are humongous. Secondaries are, well, 3 times as big. But it would be nice. I want to power it up and see. But it would be neat if they did a 12 and 12. You know what I'm saying? Like the old regulated power supplies, they used to do a double secondary winding, 12 volt, 12 volt, give you 24 volts, and that's what they regulated. That would be cool here, because then, in effect, I could have a 12 volt unregulated supply, and a 12 volt unregulated supply. Not for radio crap, but say quick dirty charging a car battery, or you know, parallel them. Bam. You parallel them, and you got 60 amps. The transformer has uses, provided that that's what this is 12 and 12. 12 and 12 is used very roughly. 12 and 12 off a secondary could be anywhere from 12 volts to 17 volts. Because obviously, you do the math and calculate the amperage of the transformer versus the inputs, the whole 9 yards, and the voltage sag as soon as you load it. So if you end up with 17 volts under the proper, not stressing it, nominal load of the transformer should mellow down to around 12 volts per coil. So, that's why I think 12 volt in general. These are your regulators. They went to this board, which pretty much was all it is a smart variable resistor. So you can pretty much it detects what your power voltage is. You can put these together or just leave them apart. It don't matter. You'll still get power out. You just won't have any control over it. That's what this is for. Through this, then they could control these 2 phases here. These 2 secondary phases. Oh, almost lost this piece of wire. This one is a useful wire. Take this crappy cap off of it. And this will make a decent interconnect. Maybe. There we connected black. Won't be needing this because, well, if I do use these for interconnects, I'm not going to be on anything that was originally in it. So now we move this over there. We're going to take this beastie and we're going to pull this apart. And it's got juice in it. I got to drain the juice. Oh, I guess it's dead. Good. Because if you don't drain the juice, you short these by mistake. Oh yeah, big old bam! Everything on here is Ellen. Too small. Oh, they're straight. These are pretty easy to take apart. I'll do the video. I'll just let the video rip. Normally I don't record because it just takes a while to disassemble things, and I always end up with unforeseen issues. But I'm not like BBI and the rest of them. You know, I screw up or glitch, well, so be it. Let it be on video. I ain't gonna scrub the video and edit that crap out. You know, that's childish crap. When you try to portray yourself as a god, then you got a problem in your own mind. I have to remove all these, or these end caps won't come off. See, this is how you take these apart. It looks logical. Hope I got 4 here too. But I do know that these have got to come out, and these adapters, because there should be interconnect bars that these look to, bolted to the caps. We need to undo those and keep just the caps. Oh, of course, they got a different size for that. Anything to make somebody's life a little bit more miserable. Pretty good at picking sizes, though. Let's get these back ones. Oh, there's the inserts. Okay. Let's get these back 4 out. This whole thing should disassemble with no problem. Let's see if I know what I'm talking about. Reason why I got to pull the screws out the end of this is peened over a little bit. So the screws kind of get stuck in it. Made in China, as Mr. Trump would say, China. China. Oh, everything's made in China nowadays. Uh-oh. That one's not undoing. Glitch. Now this is where self-gods would edit the video and make it look like there was no problem. There we go. We got it. All right. There we go. Unplug that. I don't need the power meter, the voltage gauge. All right. fuck hope they are discharged. Because I can't get these screws out. What is this? Okay, they're discharged now. We have a little sparkage there. Gotta get this shit out of here so you can get these unmolded. Ay, ay, ay. Alright. These are normal caps. These are super caps. We don't care about those. We want these normal caps. Now I need to undo this bridging which I have. Because these are going to be planted inside there. I also got to take the power supply apart, take the board out of it, and because I'm not going to put the whole power supply in there. That's, you know, that's not even hacking. That's just half-ass trashing. We don't play that. Alright. Will this wrench fit? Probably not. Yes, it does. A tool for everything around here. I'm sitting there trying to turn the wrench. Technically, these caps are probably in reality maybe like 1 farad. Maybe on a good day I could test them, but maybe 1.5. I'll say a safe 1 farad, which is, as I said, plenty. And now, as you can see, plenty of room to mount them in there. They're properly marked. Little beaners. Just never short these suckers when you charge them up. Somewhere around here I got another one of these same exact screwdriver. I bought 2 of the same thing. And just a 2 farad that's in there. I was in a hurry and I was undoing all the power supplies over here. And I needed to drain it down. I couldn't wait for it to drain down because I was impatient. I said, screw it. Stuck the screwdriver across the cap and BAM! Blew a big chunk right out of the shank. Like half the shank is missing. It just blew it into a nothingness. So yeah, gotta watch shorting these suckers. Not a good idea. Amperage wise, when fully charged, probably about 100 amps, roughly. Over 200 amps on a 2 farad. So, and it's not like 100 amps of start your vehicle. It's 100 amps of 1 second discharge. Not 100 amps of, well, charge them up, put them on your car and crank it over. You wouldn't even get a click out of it. Because they discharge that quick. They're not meant as power storage. So, alrighty. I can quit blabbing. I got to, well, while you're here, we'll just take off the main cover of this. This power supply I modified. I used to have like a really wimpy, you know, faggot 2-foot cord on it. Totally useless, you know, unless you wanted to hang the power supply off your wall next to your outlet. So I put a outlet on it and a power switch. Same as I did for Sam's, you know, which I'm sure he conveniently forgot or will refuse to say that I did anything good for him. But that's neither here nor there. But yeah, these are good power supplies. I do get a little noise out of this one. Down in the broadcast band. But I can take care of that. I know where that noise is being generated in here and what it's from, so I will just, are you checking out the goodies there, Cat? I will just filter that out with some high-grade ceramic capacitors. And it's not a lot of noise. Like if I'm listening to WHAM, I'll hear like this. You know, it's like a drifting kite carrier. You know, it drifts up and down the broadcast band, randomly up and down. So, but if this is going to be used for a linear, I wouldn't be using this and being on the broadcast band. Wow, this sucker collected dust. Holy shit. Got some dusting to do. Got some dust bunnies in here to carry your ass away. Look at this shit, bros. Look at this shit, bros. See, that's what happens when you got a small case and a lot of pressurized airflow. You know, it literally, plus, just like a PC, you should not have it down on the floor. The floor level is where when you walk in, you're kicking up dust. Cat fur, as you can see, that's about what 99.99% of this is. You know, it gets kicked up. So, looks like I got a little cleaning to do. And by the way, the noise I was describing is coming from this switching board, this oscillator. So, let's put some filters on this oscillator and that'll get rid of that. Unmount this control. I'll put that control in the front of the power supply. That's a voltage control. So, this is gonna be sweet. Sweet, sweet, sweet. Alrighty, I got some works to do. I'm gonna pause the camera. Well, stop the camera. Upload. This will be segment number 3 of the power supply build. And next time I start a new segment, we'll have this cleaned out. Have this in there. Hopefully have a home for both of these caps. And don't know about wiring yet. We'll see about that. So, until the next segment, see ya! Hello everybody. Make sure this thing's recording. Yep. Well, I'm at an impasse here. Well, it's not impasse because it's not impassable. I'm at a point of decision. Many decisions at once. Airflow, electrical installation, wire routing, and mounting, all at the same exact time. They all have to be done at the same exact time. So, I could mount the board something similar to that right there, but I don't really like that. It just doesn't look like an efficient use of space. A lot of waste. another scenario, but mind you, these are the main transistors here. Right here, the main outputs. Air is meant to flow through this to cool these transistors down. Now, I could mount it similar to that, which looks sweet. I mean, looks nice. But now I'm having a problem with airflow in heat sinks. So I thought of another scenario. Mounting it here, just like that. It's happy as a pig in slop. Utilize one of these heat sinks. Okay. Line up existing holes. Drill some holes in the heat sinks on the power supply. And voila. I could have cooling like that, which still looks really, really nice. Clears everything that I would need for the power switch, which is right here. When I go put it back in. The only thing is the AC's here, DC's here, my output's here. So I would actually have to run from the AC up in between here and into these two. I don't know. Just haven't figured out. I really like it right there. It's really nice. It's clean. Well laid out. Easy to get from here to the outputs. From here to our, which are going to be stacked caps right here. They're going to be stacked and bonded right there. So, I don't know. I got vents in the top for air to come in and be sucked out. So, I don't know. Just trying to figure this all out right. You know, and if I really wanted to, I could probably mount these this way. But then if I want to add more capacitors, then you can't. This way is a lot more logical, because if you want to add more capacitors, you could also stack them and just keep, you know, like logs. You know, and just keep paralleling them. So, you know. And to block off these holes, I'm going to take and flatten out these screens similar to this. Do a much better job when I'm ready to do it. Okay, cut them, and well, I could actually just sit down with it. This way, airflow could be used if I leave them like this. Air will come in those holes. Fingers can't get in them. You know what I mean? So, these screens definitely have a use. I just haven't gotten that far. I probably will mount them now. I don't know if I want to use the whole screen or cut them. If I use the whole thing, it's a lot of wasted material. But if I cut them, then I only need to cut for what the hole is. So I think I'll cut them because I'll be able to do all four with one versus using one per side. So we'll do that. Yes, they didn't cost nothing. They're garbage from leftovers, but I don't throw nothing away. I keep old brackets, you know. I keep all this stuff. Yeah, that stuff is just recently, the last day or two, from radios that I've just scrapped out. Chassis and stuff, mounting brackets. They just kind of landed there for now. when I'm done making my mess, then I'll go through and clean all this back up. But yeah, I think it's a lot wiser to go and cut the ones I need for this on both sides, mount them, bond them, because I could get all 4 out of one of these versus just doing one side. So there you go. That'll be, so these are not open, because if I mount this here, same thing applies. You'd be able to stick your finger in there and touch the circuit board, which would, you'd be thinking, baby, light my fire. So, you know, we'd be blocking them babies off. And this way you can't stick your fingers in there. Cool beaners. I really like the way that looks right there. Easy to adjust if I don't put the power control up front, which I still might do it right through this, which used to be the power light. I don't know. I'll probably just leave it alone at first. Stick it in the rack. Beat the hell out of it, make sure it's happy before I go. Oops, before I go and put my digital meters in it and stuff. Because I can mount all this all unbolts off there to mount all that. So it's not like, you know, I got to do that now. But all this I need to do now. And I'm just not sure exactly where I'm going to be with all this. So now, with you guys, I figured out the screening I'm going to do. She said I'm really leaning towards utilizing the existing holes here. Drill some holes into these heat sinks, thread them, you know, and then I can, you know, mount this right directly to these heat sinks, and therefore it should be able to easily dissipate or load heat vertical, you know, because heat rises, so you want it to come off the fins. You don't want fins like that. You don't want horizontal fins. You always want vertical fins. You know, yeah, I'm going to be running a fan, so I'm going to have forced air cooling, but I also still want radiant. I want heat to be able to come up off of them very easily. Plus, with this being vented, this fan running is going to be sucking air in. It's going to be coming across smack and then to the fan. So it's going to be pressurizing, you know, this little bit of extra space right here. And then being sucked out. So yeah, I think that's what homie's going to do. Actually, I can mount that all the way back. That would allow me more mounting stability. It'll isolate the 110 down there in its own cubby hole, which would just have 2 wires running up here to my switch, and then up, you know, here and then back down. And then we just have our 12 volts come right across the top. That looks nice. You tell me in the remarks below. Tell me if I should mount it like this. You know, drill the holes, mount the heat sinks like that. Or take, because if I do it horizontally, I need to have this heat sink in the airflow of the fan. So therefore the power supply board would have to be right about there, which also puts my outputs awful close to the AC input. So I don't think I like that. You know, and I could flip it, but now the DC is here, so I got to run all the way up to here. I can put the caps here, but now they're, yeah, I probably couldn't do it. Yeah, I don't know if I like the caps too close to that ACL. That just not. That's just kind of bad mojo. So I don't know. I could mount it up there centrally, and put brackets in to mount these. Send me in the middle like that. That's still electrically safe. Plenty of airflow then because I'm not blocking off any, but I would still need the heatsink because it's planted horizontally on the floor, so I would still need that. I don't know. As I said, tell me in the remarks below. Should I put her in the front, like you see here? Or mount her on the side, like you see here? You gotta be perfect. They're gonna roll around until the mounts are in there. But you get the idea of where they're gonna be. So, alright, I'm gonna end this video. Upload it to Facebook. I'll be keeping a watch on this post. You guys let me know in the remarks below. On front, side, or center bottom. Let me know. See ya. Well, we're done. We got her complete. Sorry I didn't do any more segments of videos, but I never get it built if I keep doing videos. So, we got 14.7 volts. I hope you can see that. So that's all good. Hook these. See, a lot lighter than it was. You don't need a damn forklift to move the power supply. And power switch, power light. There's our exhausting fan. So she's sucking air in and exhausting it out. We got our grates, so fingers can't go inside the power supply. She's golden for now. She's just got two connections on the back. I want to put some 100 amperes up front, and I want to upgrade these back here to something a little better. Maybe add another set back here. And clean it up, and guess we'll run it. See how well she runs. With the caps in there, the fans and everything stay running for quite a while after you turn it off. Give you an idea. Now you can see that fan running. She's unhooked. And she's dropping down. I put a small floating resistor in there. Otherwise it would just stay charged up continuously. So there it is. It's all good. You see the rates, you see the caps inside it. So I gotta take out this piece of junk radio here. I'll just power supply into there. We should be golden. I can put that back where it belongs. Alright. See ya.